start so that you can continue to eat and have some of your lunch to yourself if you'd like. So I'm Mr. George. If you haven't met me, I am your stats consulting advisor, coach person for your ISEP project. I teach AP Stats here. I have studied statistics in my post-grad work, so I am a good resource for you in getting stats into your project. The purpose of this presentation is to do just that. Why do you need to come do stats? You thought you were doing science, why do you all of a sudden need to come talk to a math teacher? Here's the reason why. First, let's make this work. What is it? Let's try and close. There we go. First, what is statistics? So these are the four facets of statistics. Collecting data. This is something, how many of you have already collected your data? Okay. So how many people are still in the process of collecting? And the rest of you have not started? Okay. So stats is concerned with how you collect your data. One thing, and hopefully Danielle and Jennifer, they've talked to you about like the importance of randomization in your experiments and of replication in your experiments and control. Right? These are all things that statisticians also worry about. These are the important parts of your experiment that make all of our statistics valid. Make it so that they make sense and that we can actually come to some conclusions about what happened in your experiment. So, unfortunately, when we meet, you've already done the data collection. I might ask you some questions about how you collected your data. That's so that we can make sure that everything we're going to do is valid. So, be ready to be thinking about, like, how did I randomize in my experiment? How did I use replication? How is there levels of control? Things like that. Then we describe data. This is probably the thing you're familiar with. You've made charts and stuff, means, medians, modes. That's stats, right? Those are descriptive statistics and things the way we look at data and even analyze them. The new part, and what most of what you're going to talk to me about, is this last thing. Inferring meaning, inferential statistics. Figuring out, did something happen, or was this just what I expected to happen? So let's talk a little bit more about descriptive statistics. So this is where you will all do this in your board. You will display the data that you produce in your experiment. You're going to want to have probably some easy to understand charts and graphs and tables, showing like, here's the stuff that happened. Here are the trends that I'm seeing. Here's the distribution of what the stuff was that I measured. Those are things people want to see so they can understand what you did. You're also going to, you're going to want to describe the things in those charts. You're going to want to describe like the center, meaning like what was common, what did you see that was typical, right, for your experiment. But most importantly, the spread. How much did things vary? Right? Every time you did your experiment, you probably weren't getting the exact same result. We're really interested to see how much it was varying. It's an important part of understanding what's happening in your project. This is stuff that you may be able to handle on your own. Maybe you feel comfortable enough making charts and graphs in Excel, getting summary statistics, and writing about them. If that's what you do, great, do that, and then you can still bring it to me and I can check it. Maybe this scares you. That's okay too. This is something we can talk about if you make a meeting with me as well. Questions on descriptive statistics? All right. The big part is inferential statistics. So this descriptive stuff is good. It shows people what happened, but it doesn't tell people if something important happened. So now we want to know, are the differences or the relationships that you saw, are they real? Did like the factor that you were using, the treatment you used, did it actually cause something to happen? Did it cause a difference? We're looking for this special term. Did something statistically significant happen? And there's a way to mathematically check that. And that's going to be what we do to get it. We're going to be looking for what's called a p-value. Have you already heard the word p-value mentioned to you? Maybe? Yeah. So I'm going to try to, real quickly, in 5 minutes, explain what I take all second semester of AP Stats to do, which is explain the p-value. Okay? So the idea is that we want to know how likely was it for you to get the result that you got given what we assumed to happen in the experiment. It's a complicated sentence. How likely was it for you to get the results that you got, assuming that something else was going to happen, some predictable thing we thought was going to happen was going to be true? That's what a p-value is. It is a probability. Here's an example, a coin example, to give you an idea. Somebody comes up to you with a coin, and they're going to flip it, heads or tails, right? We want to know, are they trying to trick you? Are they cheating with some coin that is not fair? A fair coin would have a 50% chance of heads, a 50% chance of tails, right? If they came up to you, and you got to test it first, and you flipped it 100 times, how many times would you expect to get heads, and how many times would you expect to get tails? 50-50, right? So let's say you do that. Like the person comes up to you, they want to play this game with their coin, you're like, wait, let me test it, I want to see if it's fair or not. You flip it 100 times. So you flip it 100 times and you got 52 heads. Does that mean it's an unfair coin? Does that mean it's more likely to come up heads? Well, every time you flip it 100 times, you're not going to always get 50 heads, 50 tails. You're going to get some variation, right? So what we have to ask ourselves is, how unlikely was it to get 52 heads or more? Is it that unlikely to get 52 heads? Statistics gives us a way to actually calculate the probability of that. It turns out, I did the math, there's a 34% chance that if the coin was fair, you would still get 52 out of 100 heads 34% of the time. Does that make you think that a coin is unfair? Is 34% something that happens a reasonable amount of time? Yeah. So I would say here that that's not enough evidence to say that the coin is unfair, right? 34% of the time is pretty common. We need to see something more unusual to believe that this coin is unfair. So somebody else comes up to you with a different coin, you do the same thing. You test it, you flip it 100 times. This time you got 60 heads. You go through the math. How unusual is it to get 60 or more if the coin was really fair? Turns out that only would happen 2% of the time. How do you feel about this coin? Suspicious, right? Only 2% of the time would come up 60 heads. Maybe this is not a fair coin. Maybe this one's weighted more towards heads. Now, this is actually our p-value, right? We're only 2% chance of this happening. I'm suspicious. I now have enough evidence to think about rejecting my hypothesis that it was a fair coin. This is an example of some of the language I'm going to help you start to craft when you start doing these inferential tests and these inferential statistics. This is just a peek at it. The idea is that you make an appointment so that we can maybe meet once, twice, 3 times in order to iron out and get your statistics right. So how do you make an appointment? You look on the box that's on that sheet that I handed out. That's a reminder, it's also here. So on Google Classroom, and I'll pull it up right now, I made this for you. So in Google Classroom, under the classwork, there's this one that says Stats Consulting Session. If you click on this Google Sheets, it'll open up this, which has slots for you to fill in your name for when you want to come meet you. Notice some people have already done it. You cannot erase other people's names. Those are already taken. Black boxes are for when I have other things going on, I couldn't meet those times. But everything else is available, right? If you can't find a time that works for you, if you want to email me, we can maybe work something off the books. But try to fit it into one of these dedicated spots. These are all 30-minute slots. And if you think you need more, I would suggest doing one, we'll talk, and then we can set up a second visit. Okay? Let's say you are booked for a meeting next week. Sometime before your meeting, if you could email me or share with me through Google Drive your data and a description of what your experiment or project's about, it would go a long way to making our meeting more efficient. So that I already come into it knowing, oh, you did this, you have this, and now we can talk about what you need to do. And then we don't have to waste time talking about what's going on. We can just jump right into the stats. My email is on the handout. It's also on the Wesleyan webpage. You should be able to find it. Questions? Y'all think you know what p-value is? It's okay. All right, I'm going to stick around here if you have questions.